Time travel. The very concept sparks a fire in our imaginations. It whispers promises of revisiting cherished memories, righting past wrongs, or glimpsing the future that awaits. From H.G. Wells' iconic time machine to the DeLorean speeding through the decades in Back to the Future, the idea of manipulating time has captivated humanity for generations. We are drawn to the possibility of altering our own personal timelines or witnessing pivotal moments in history. This innate desire to control time stems from our fundamental understanding of its linear nature. We are born, we live, and we die. This unidirectional flow of time creates a sense of urgency, a desire to savor the present while simultaneously yearning to explore what was and what could be. Time travel offers a tantalizing escape from this linear trajectory, a chance to break free from the constraints of chronology. The allure of time travel extends beyond mere escapism. It taps into our deepest curiosities about the universe and our place within it. Could we one day unravel the mysteries of time itself? Could we bend it to our will, traversing the vast expanse of history and the unknown future? These questions drive our fascination and fuel the ongoing exploration of this captivating concept. The potential to witness the birth of stars, the rise and fall of civilizations, or the evolution of life itself is an irresistible siren song for the inquisitive mind. The concept of time travel isn't solely a product of modern science fiction. Its roots can be traced back through centuries of mythology, folklore, and philosophical thought experiments. Ancient tales often feature characters transported to different eras through magical means or divine intervention, reflecting an early human fascination with manipulating time. These stories, passed down through generations, laid the groundwork for later explorations of time travel in literature and popular culture. The Mahabharata, an ancient Indian epic, tells of King Kakudmi, who travels to the abode of Brahma, the creator god, only to return to Earth centuries later, highlighting the relative nature of time. Similarly, Japanese folklore speaks of Urashima Taro, a fisherman who visits an underwater palace and returns to his village to find that centuries have passed. These narratives explore the consequences of disrupting the normal flow of time and the potential paradoxes that might arise. As science began to emerge from the shadows of myth and superstition, the concept of time travel began to take on new forms. Early scientific thinkers pondered the nature of time and its relationship to space, laying the groundwork for later theories. The development of clocks and calendars demonstrated humanity's increasing desire to quantify and control time, further fueling the dream of manipulating it at will. In the late 19th century, H.G. Wells' novel, The Time Machine, solidified time travel as a staple of science fiction. Wells' story, featuring a scientist who builds a machine capable of traversing the timeline, captured the public imagination and inspired countless subsequent works, exploring the possibilities and perils of manipulating time. This marked a turning point, shifting the concept of time travel from the realm of mythology and philosophy to the domain of scientific speculation. With modern physics, particularly Einstein's theory of relativity, time travel moved from fantasy to theoretical possibility. Einstein showed time is relative, intertwined with space to form space-time. Special relativity introduced time dilation, verified experimentally. General relativity expanded this, showing gravity's influence on space-time. Massive objects warp space-time, causing gravitational time dilation. These theories suggest time is dynamic and flexible, potentially manipulable. Einstein's work fuels ongoing research and speculation into time travel. Long before modern physics, humans wove tales of temporal manipulation into their myths and legends. These stories reveal a fascination with altering the flow of time. They reflect a desire to revisit the past, glimpse the future, or escape the present. These narratives were early explorations of time travel. Greek mythology's Kronos symbolizes time's relentless march. This highlights anxieties about time's unstoppable nature. The myth underscores time's perceived power. Hindu mythology's Yuga cycles describe vast periods of time. These epics represent a cyclical view of time, suggesting the possibility of returning to previous ages. These early narratives demonstrate the fascination with time travel, reflecting our desire to transcend temporal limitations. Myths laid the groundwork for later explorations of time travel. As human civilization progressed, the concept of time travel began to find expression in various forms of art and literature. From ancient epics to modern science fiction novels, writers and artists have explored the possibilities and paradoxes of manipulating time. These creative works served as thought experiments, exploring the potential consequences of altering the past or glimpsing the future. One of the earliest examples of time travel in literature can be found in the Japanese folktale of Urashima Taro. A fisherman, he journeys to an underwater palace, and upon returning to his village, discovers that centuries have passed. This story explores the disorienting effects of time travel and the potential for irreversible change. Early explorations of time travel were confined to myth and fiction until scientific inquiry offered new perspectives on time. Early thinkers laid the groundwork for later revolutionary theories. Newton described time as absolute in Principia Mathematica. Einstein's work challenged this view, reshaping our understanding. Precise time measurement opened new scientific avenues, leading to the theory of relativity and the possibility of time travel. At the dawn of the 20th century, Albert Einstein revolutionized our understanding of the universe and time. His theory of relativity challenged the Newtonian view of absolute time, proposing that time is relative and linked to space. This concept shattered the traditional view of time as a universal constant. Einstein's special relativity introduced spacetime, uniting space and time into a single entity. Time is not independent but interwoven with space, creating a dynamic fabric. This interconnectedness has profound implications for our understanding of the universe. Time dilation, a consequence of Einstein's theory of special relativity, suggests that time is not an absolute constant, but rather a relative quantity that can vary depending on an observer's motion. This opens up the tantalizing possibility of time travel, albeit in a limited sense. While traveling to the past remains firmly in the realm of science fiction, time dilation offers a potential pathway to journey into the future, albeit not in the way often depicted in popular culture. Imagine a spaceship traveling at a significant fraction of the speed of light. For the astronauts on board, time would pass normally. However, for observers on Earth, time would appear to slow down for the spaceship and its occupants. Upon returning to Earth, the astronauts would have experienced less time than those who remained on Earth, effectively having traveled into the future. This scenario, while seemingly fantastical, is a direct consequence of special relativity. The effects of time dilation are not merely theoretical, they have been experimentally verified. Highly precise atomic clocks flown on high-speed jets have shown a measurable difference in time compared to stationary clocks on Earth, confirming Einstein's predictions. While the time differences observed in these experiments are minuscule, they demonstrate the reality of time dilation and its potential for future applications. However, achieving significant time dilation for human time travel would require reaching speeds approaching the speed of light, a feat that presents immense technological challenges. The energy requirements for such speeds are astronomical, and the effects of acceleration on the human body would be severe. While time dilation offers a theoretical pathway to the future, the practical hurdles remain formidable. Despite these challenges, time dilation remains a fascinating concept with potential implications for future space exploration. Einstein's theory of general relativity shows gravity as curved spacetime affecting time flow. Time slows in stronger gravitational fields, verified by technologies like GPS. Wormholes, theoretical tunnels in spacetime, could connect distant points, enabling faster-than-light travel. Their existence and stability remain speculative, requiring exotic matter. Kip Thorne's research on traversable wormholes explores conditions for stable passage using exotic matter. This work bridges speculation and scientific inquiry. Traversable wormholes face challenges like causality violations and stability issues. These potential dangers necessitate further research. Wormholes remain theoretical, with no observational evidence yet. Scientists explore gravitational lensing and energy signatures for potential detection. Time travel paradoxes, like the grandfather paradox, challenge our understanding of causality. These paradoxes raise questions about the nature of time. Time travel could disrupt causality, illustrated by the butterfly effect. Ethical concerns arise from potential unintended consequences. The true nature of time remains a profound mystery, with theories suggesting it may be emergent or quantized. Our perception of time may not reflect its underlying nature. Time travel concepts, from relativity to wormholes, push scientific and philosophical boundaries. Theoretical challenges and paradoxes highlight the complexity of altering time. The possibility of time travel is not without its profound limitations and ethical concerns. The paradoxes associated with time travel, such as the grandfather paradox and the bootstrap paradox, raise fundamental questions about the nature of cause and effect. These logical inconsistencies suggest that time travel, particularly into the past, might be inherently impossible or require a more advanced understanding of time and the universe than we currently possess. Even if time travel were feasible, the potential consequences of altering the past or future are fraught with danger. The butterfly effect illustrates how small changes in the past could lead to drastic and unforeseen consequences in the present, potentially altering the course of history in unpredictable ways. This raises significant ethical questions about the responsibility of those who might possess the ability to manipulate time. The practical challenges of time travel are equally daunting. Achieving the speeds necessary for significant time dilation requires technology far beyond our current capabilities. The immense energy demands, the potential physical effects on travelers, and the dangers posed by gravitational forces near massive objects all present significant obstacles. Similarly, the creation and stabilization of traversable wormholes depend on exotic matter, which remains purely hypothetical at this stage. Moreover, the ethical implications of time travel extend beyond the potential consequences of altering history. The very act of time travel could disrupt the natural progression of events, leading to unintended and potentially harmful outcomes. The responsibility of wielding such power would require careful consideration and a deep understanding of the potential ramifications, both intended and unintended. As we stand on the threshold of understanding time travel, it is clear that the concept remains one of humanity's most intriguing and elusive dreams. The scientific theories and discoveries of the past century have provided a tantalizing glimpse into the possibilities, but they also highlight the immense challenges that lie ahead. Time travel, if it is possible, will require advancements in technology, a deeper understanding of the universe, and careful consideration of the ethical implications. Looking to the future, the exploration of time travel will likely continue to inspire scientists, philosophers, and dreamers alike. Advances in our understanding of quantum mechanics, the nature of space-time, and the potential existence of exotic matter may one day bring us closer to realizing the dream of time travel. However, it is equally likely that new discoveries will raise even more questions, challenging our assumptions and pushing the boundaries of our knowledge. The allure of time travel lies not only in its scientific possibilities, but also in its profound philosophical implications. It challenges us to consider the nature of reality, the limits of human knowledge, and the ethical responsibilities that come with such power. Whether or not time travel becomes a reality, the exploration of its possibilities continues to expand our understanding of the universe and our place within it. In conclusion, the mystery of time travel is far from being solved. It remains an open question, a tantalizing possibility that continues to captivate our imaginations and drive scientific inquiry. As we look to the future, we can only hope that our journey towards understanding time travel will lead to new discoveries, deeper insights, and perhaps one day, the realization of humanity's timeless dream of traversing the vast expanse of time.